Hello everyone, welcome back to our channel gsipucmysuru. This is the second session of the fourth chapter, Passive Electronic Components. In the last session, we discussed the difference between the active as well as the passive components, and we saw the examples for both passive as well as the active components. And we also started with the very first passive component, that is the resistor. We saw its definition and some of the specifications of the resistor. So in today's session, we will be continuing with the further topics of the same chapter. So the very first topic is the specific resistance or resistivity. So what exactly is the meaning of the specific resistance or resistivity? At constant temperature, the resistance of a conductor is directly proportional to the length of the conductor and inversely proportional to the area of its cross section. So the resistance, which is denoted by the letter R, is directly proportional to the length of the conductor, and it is inversely proportional to the same resistance R is inversely proportional to the area of cross section. So R is proportional to L, that is length of the conductor, and inversely proportional to the area of cross section. When I am going to combine these two, I will be getting the resistance R is proportional to L divided by A, where L is again the length and A is nothing but the area of cross section. And this proportionality constant will be replaced by rho, which is nothing but the specific resistance or the resistivity. And the specific resistance or the resistivity depends upon the material of the conductor. So the specific resistance or the resistivity is given by this formula, R is equal to rho into L divided by A, where rho is called as the proportionality constant, rho is called as the specific resistance or resistivity. When I want to calculate the SI unit for this rho is equal to, if I cross multiply, R into A divided by L, and the unit for resistance is ohm, and the unit for area of cross section is meter square. The unit for the length of the conductor is meter. So this gets cancelled with this, so I will be left with ohm meter. So the SI unit of the specific resistance or the resistivity is ohm meter, which will be denoted like this. So coming back to the same expression, rho is equal to R into A divided by L. This specific resistance rho will be equal to R when the area of cross section is equal to 1 meter square and the length of the conductor is equal to 1 meter. So the specific resistance of a conductor will be equal to its resistance when a unit length of conductor is taken having a unit cross sectional area. So this is all about the specific resistance or the resistivity. The next topic is conductance. So what exactly is this conductance? We already know about the resistance. Resistance is the property of a material to oppose the flow of current, whereas this conductance, which is denoted by the letter G, capital letter G, is the reciprocal of the resistance, that is G is equal to 1 divided by R. R, resistance, is nothing but it opposes the flow of current, but here the conductance, it allows the flow of current. It is the property of a material to allow the flow of current, which is nothing but the reciprocal of the resistance, and it is always measured in terms of Siemens, SIEMES, which is symbolically represented by S. So the conductance as well as the resistance are both inversely proportional to each other. Now let us solve a simple problem on the specific resistance or the resistivity. The problem is the resistance of a wire of length 1 meter, that is L is equal to 1 meter, and of diameter 0.12 millimeter. They have given the diameter of the wire, which is equal to 0.12 millimeter, is 40 ohms. The resistance of a wire which is having a length of 1 meter and diameter of 0.12 millimeter is 40 ohms. R is equal to 40 ohms. What is its specific resistance? Specific resistance is nothing but rho you have to find out. This rho for the given length of the conductor and diameter as well as the resistance. We are having this formula R is equal to rho into L divided by A. You have to find out rho. So, let us alter this expression. Rho is equal to R into A divided by L, where L is nothing but the length, which is equal to 1 meter. R is nothing but the resistance, which is equal to 40 ohms, but I don't know the value of A, that is nothing but the area of a conductor. But here they have given the diameter. We know that whatever the conductor we are taking, it is circular in shape. So, in order to find out the area, I can use this diameter, that is the diameter of the conductor, which is nothing but the diameter of a circle. So, what we are going to do is, in order to find the area, we are going to use the expression of the area of a circle, which is nothing but pi r square, where r is nothing but the radius, which is equal to half of the diameter. So, pi into d divided by 2 whole square, which is equal to pi d square divided by 4. D square, 2 square is equal to 4. So, rho is equal to r into pi d square divided by 4L. Like this I can easily calculate the specific resistance. Now let us substitute the values directly. R value is equal to 40 ohms, pi 3.14 and D value is 0.12 into 10 to the power of minus 3, because millimeter, 0.12 millimeter. So, 0.12 into 10 to the power of minus 3 whole square, because it is D square, whole divided by 4 into the length of the conductor is 1. So, divided into 1. So, 4 ones are 4 tens are. So, after solving this expression or after solving this equation, I will be getting a rho value as 0.45216 into 10 to the power of minus 3 whole square, which is equal to 10 to the power of minus 6, and the unit for this resistivity or the specific resistance is ohm meter. So, the final answer for this problem is 0.45216 into 10 to the power of minus 6 ohm meter. So, in this problem they have not given the area directly, but they have given the diameter. So, using the formula of the area of a circle, you have to calculate A and then substitute its value in the formula. Clear? Now, we will move on to the one more problem of the same topic. The problem is calculate the resistance of 100 meter length. Second problem is calculate the resistance of 100 meter length, L is equal to 100 meter, of wire having a uniform cross sectional area of 0.1 millimeter square. So, area is equal to 0.1 millimeter square. If the wire is made of manganese having a resistivity of 50 into 10 to the power of minus 8 ohm meter. Resistivity is given, which is equal to 50 into 10 to the power of minus 8 ohm meter. For these values you have to find out the resistance. In this problem the length, area as well as resistivity is given, for which you have to find out the resistance. We are having this direct formula R is equal to rho into L divided by A, but here A is nothing but the area of cross section, which is equal to 0.1 millimeter square. So, 0.1 milli is 10 to the power of minus 3 millimeter square and 10 to the power of minus 3 whole square. So, you have to use the A value as 0.1 into 10 to the power of 3 into 2, which is equal to 6. So, 0.1 into 10 to the power of minus 6. So, let us solve this problem for the given values of rho, L and A. Rho value is 50 into 10 to the power of minus 8. L value is 100 whole divided by A value is 0.1 into 10 to the power of minus 6. I am writing it directly. So, after solving this, I will be getting R value as 50,000, 50,000 into 10 to the power of minus 8, and 10 to the power of minus 6 is in the denominator. When it goes to the numerator, it will become 10 to the power of plus 6. So, 10 power plus 6 gets cancelled with minus 8, retaining minus 2. So, R is equal to 50,000 into 10 to the power of minus 2. When I am going to solve it, I will be getting 500 ohms. 50,000 divided by 10 to the power of plus 2. We can do that, or you can shift the point towards the left to 2 places in order to cancel this. So 500 ohms is the final answer for this problem, for which length, area as well as resistivity is given. Clear? Now we will move on to the next topic, that is types of resistors. These resistors are broadly classified into two types, that is fixed resistors and the variable resistor. So they are broadly classified into two types, fixed resistors and second one is variable resistors. So now let us try to understand what exactly is this fixed resistors and variable resistor. Fixed resistors are the resistors in which the value of the resistance will be constant. So value of resistance is constant. So its value is fixed, its value is constant, you cannot change its value. Under this fixed resistors, we are having a number of other types like carbon composition resistor, carbon composition, metal film resistors and wire wound resistors and surface mount devices. And these resistors like carbon composition, metal film, wire wound and surface mount devices are classified depending upon the material what I am using to construct these resistors. So typically these resistors are classified into fixed as well as a variable resistor, and these fixed resistors are furthermore classified into carbon composition, metal film, wire wound and surface mount devices depending upon the type of material what I am using to construct these materials or construct these resistors. So in this fixed resistor, the value of the resistance will be constant, it will not be varied. Coming to this variable resistor, the resistance value can be varied over a specified range. So resistance value can be changed or varied for specified range. So what exactly is the meaning of this? So we are having a number of different types of variable resistor using which the value of the resistance can be varied from a given specified range. Say for example, I am having a variable resistor whose value can be varied from 1 ohm to 100 ohm. So I can use this variable resistor which is having a specified range of 1 ohm to 100 ohm and set the different values of resistance. Suppose if I want to set the resistance value as 55 ohms, then I can use this variable resistor and set the value of the resistance to 55 ohms. In the same way, if I want to change its resistance value to 80 ohms, then I can use the same resistor in order to change the resistance value to 80 ohms. So for a given specified range, I can change the value of the resistance. And again, depending upon the material what I am using, these variable resistors are classified into potentiometer, rheostat and preset, etc. There are a number of other types of variable resistors also. Some of the types are potentiometer, rheostat and preset. In the introduction to apparatus session of the lab, I have already talked about this decade resistance box using which I can vary the resistance value over a specified range. So these are some of the different types of variable resistor. So what exactly is this variable resistor? Variable resistors are the ones in which the resistance value can be varied over a specified range. Depending upon the material what we are using to construct the resistor, these variable resistors are furthermore classified into potentiometer, rheostat as well as preset. So now let us see in detail about these different types of resistors, but before that let us try to see the symbolic representation of these resistors. Circuit symbol of different types of resistors. We already know that the resistor can be represented like this. This is a fixed resistor. The So we can symbolically represent the fixed resistor like this. And coming to a variable resistor is the one in which the resistance value can be varied over a specified range. Then we are going to write this resistor with a arrow mark symbol across that resistor. So this is the symbol of a variable resistor. So whenever we are going to use these resistors in our circuit diagram, then we must be very much clear about using this fixed resistor as well as the variable resistor. Whenever I am going to use this kind of symbolic representation, then it is very much clear that I am using a variable resistor whose value can be changed, or using which I can change the resistance value over a specified range. Then coming to a potentiometer, which is also one of the type of variable resistor, we are going to represent the potentiometer like this. Coming to the last type of symbolic representation, it is the preset. Then the preset will be like this. So in our lab, that is in electronics lab, we are going to use this fixed type as well as the variable type of resistors, whereas in physics lab you are going to use this potentiometer. Now let us study in detail about one of the type of the resistor, that is carbon composition resistor. So now let us see the first type of fixed resistor, that is carbon composition resistor, which is also called as carbon film resistors, which is usually denoted as CFR, that is carbon film resistor. And this is one of the type of fixed resistor. Here these carbon film resistors are mainly manufactured using this carbon. So what they are going to do is, they are going to take a ceramic rod, and upon the ceramic rod they are going to deposit the thin carbon particles or fine carbon particles. The amount of carbon particles deposited will determine its resistance value. And after the carbon particles are deposited, they are going to place the metal plates, metal caps at the ends of the resistor body for the connection purpose. And for that they are going to use thinned copper leads. Then this resistor element is coated with non-conducting material for the insulation purpose as well as for the mechanical strength. Later on, a number of color bands, it can either be a 4 bands or a 5 bands. The color bands will be coated on this resistor element in order to specify its resistance value, because the size of these resistors are very, very small. So they are going to use the color bands for indicating its resistance value. So let us try to understand this carbon film resistor with the help of a diagram. So here, if I am going to consider this as the resistor element, in which if I am going to consider this as the inner structure of the carbon film resistor, where the fine carbon particles are deposited on the ceramic rod. So here at the center they will be having a ceramic rod upon which the carbon particles, fine carbon particles will be deposited. On the two ends of this resistor element, metal caps will be placed made up of tinned copper to provide the leads for external connection purpose. So leads for connection purpose, and these are metal caps. And these leads are called as axial leads. Axial leads because these leads are connected in axial along the resistor element, so it is called as axial leads. After the carbon particles are deposited on the ceramic rod, the non-conducting material will be coated on the surface of this resistor element for insulation as well as for providing a mechanical strength. After that, color bands will be coated on the surface of this resistor to give or to specify the resistance of that particular resistor. Since these resistors are very, very small in size, they are going to use these color bands in order to indicate its resistance value. So fine carbon film resistors are made up of carbon particles, hence it is called as carbon film resistor, which is also called as carbon composition resistor. And these resistors are available in a range of 1 ohm to 22 mega ohms. And The power rating of these resistors is 1 by 8 watt to 2 watt. Since the power rating of these resistors are very low, it is having a very less current carrying capability, and they are also having a tolerance value up to 20%. So these are some of the features of this carbon film resistor. Coming to the applications of these carbon film resistor, applications. They can be commonly used in the circuit because of a small size, because of its smaller size and low cost. They are very cheap, so they can be most commonly used in almost all of the circuits. And the second application is it can be used in electronic circuits where accuracy is not important. So accuracy is not important. Why I can use these resistors in the circuits where accuracy is not important? Because we are having a higher tolerance value of 20%. We have already studied about this tolerance value in the lab session. So because of this tolerance value, if I want a 100 ohm resistor anta helidre, because of the tolerance value, the 100 ohm which I am going to use in the resistor, it will lie within the range of around 90 ohm to 110 ohm. So this is the range of the resistor. I am not be able to get the complete 100 ohm resistor, but its value will lie within this range 90 ohm to 110 ohm, which tell that the resistance value is not that much accurate. So I can use this carbon film resistors in the circuit where accuracy is not that important. We are going to classify these resistors depending upon the material what we are going to use in order to construct this resistor. So accordingly, this carbon film resistor has got this name because we are going to use fine carbon particles in order to construct these resistor. We are going to deposit the fine carbon particles on the ceramic rod, and the amount of carbon particles deposited decides its resistance value. So these carbon particles, after the deposition of these carbon particles, metal caps made up of tinned copper will be placed on the either ends of these resistor, and the leads will be provided for external connection purpose. And after the metal caps are placed, the non-conducting materials will be coated for insulation purpose and to provide the mechanical strength. After that, the color bands will be coated on the resistive element, on the resistor element, in order to give or in order to specify its resistance value. So these are some of the important points of this carbon film resistors. Now let us see the next type of fixed resistor, that is metal film resistor. This metal film resistor is another type of fixed resistor which is usually represented as MFR, that is metal film resistor. Just now we saw a carbon composition resistor. In that carbon composition resistor, I told you that depending upon the material what I am using to construct, accordingly the carbon film resistors are named. That is, I am going to use the carbon particles in the carbon composition resistor, hence it is called as carbon composition resistor. But here metal film resistor, here we are going to use metals in order to construct these resistors, hence it is called as metal film resistors. We are going to use the metals like nickel, chromium and aluminium in order to construct these resistors. So we are going to use these metals in order to construct these resistors, hence it is called as metal film resistor. So what they are going to do is, they are going to take a ceramic rod upon which fine or thin films of metals will be deposited. A number of layers of metals will be deposited on the ceramic rod. After that, when the fine or thin films of metals are deposited on the ceramic rod, the resistivity or the resistance of that particular ceramic rod will become very low, almost it will become 0. So what they are going to do is, they are going to remove the metal films from the rod in the form of spiral structure. So the amount of metals which is removed, or the length, the thickness and the width of the spiral will determine the exact value of the resistance. After that, they are going to place a metal caps on either ends of the resistor for external connection purpose. That is the caps which is made up of tinned copper for external connections. Later on, a non-conductive material will be coated on the resistor element for insulation as well as the mechanical strength purpose. And later, the last step is the color bands will be coated on the surface of this resistor in order to indicate its resistance value. So, coming to the structure of this metal film resistor, this is the external structure. There will be a ceramic rod. Upon the ceramic rod, a number of fine films of metals will be placed, metals will be coated. Later on, the metals will be removed from the rod in the form of a spiral. The width, length as well as the thickness of the metal what we are going to remove from the spiral, or the length, the width and the thickness of the spiral indicates the resistance value of this resistor. Then a metal caps will be provided on either ends of this resistor for external purpose, for external connection purpose. These are the two leads. And later on, a non-conducting material will be coated on this resistor for the insulation and for providing mechanical strength. And the last step is a number of color bands will be coated, that is either the 4 color band or the 5 color band to indicate the resistance value of this resistor. And coming to the other features of this metal film resistor, the value of this metal film resistor will range from 1 ohm to 22 mega ohm. And the power rating of this resistor is 1/8 watts to 2 watts, and it is having a tolerance value of just 1%. Whereas the carbon composition resistor was having a tolerance value of 20%. It was a very high tolerance value. But here metal film resistor is having a tolerance value of just 1%. So, coming to the application of this metal film resistor, it is used in the circuit where accuracy is very important. Since it is having a very low tolerance value, this can be used in the circuits in which accuracy of the resistance value is very important. So, these metal film resistors are called so because we are going to use metals like nickel, chromium and aluminum in order to construct these resistors. Hence, it is called as metal film resistors. So, on a same ceramic rod, we are going to deposit the thin films of these metals and we are going to extract these metal films in the form of a spiral, and the thickness, the length and the width of the spirals determine its resistance value. I hope you are very much clear with this carbon composition resistor and the metal film resistor. In my next session, I will be coming with the other types of resistor. Until then, take care. Bye bye.